I'm Doug. I'm the director of the New York Tech Alliance, and thank you. Before we get started, I have a few items to share with you, and please know that we record our events to share with anyone unavailable to be here this evening. Recordings are posted on NYTA's YouTube channel, and you can subscribe to our channel and view this and past recordings by going to youtube.com/New York Tech Alliance. For anyone joining us for the first time, the New York Tech Alliance is a nonprofit serving the tech community here. At the core of our mission, we drive diversity, equity, and inclusion to make the New York Tech ecosystem the most diverse and dynamic in the world. We help lower barriers and increase access to the information, knowledge, and resources people need to grow and be successful. To learn more, go to nytech.org. Special thanks to the team here at Civic Hall for everything you guys do to help deliver this event. To learn more about Civic Hall or schedule a tour, you can go to civichall.org. In case you're not aware, Civic Hall occupies floors 2 through 7 of this building. It's about 85,000 square feet. In addition to meetings and events, Civic Hall is home and host to many education partners who provide digital training skills to a wide range of people. And it also offers both individual and organizational memberships to the tech community. Civic Hall is providing a free trial membership to everyone here this evening. If you'd like to take advantage of the offer, scan the QR code on the screen and submit your information. I'd also like to recognize the FedCap group. If you're not aware, both Civic Hall and the Tech Alliance are members of the FedCap group, which is a large nonprofit that originated in 1935 to help disabled vets get jobs. And today, FedCap is a group of over 20 nonprofits that operate in the US, Canada, and the UK. Focus on 4 key things: economic well-being, education, health, and workforce development. So to learn more about FedCap Group and the amazing work that it does, you can go to fedcapgroup.org. Thanks to our annual sponsors who help make events like this one possible. Each has a presence on our website. You can learn more about them and how they support our community by going to nytech.org/sponsors. And a big thank you to Red Rob, tonight's official sponsor. Red Rob is an AI talent platform for early stage startups that democratizes access to top global talent, traditionally monopolized by big business. If you'd like to learn more about Red Rob, you can go to their website at redrob.io. Okay, I'm going to give this a shot. Benvenuti ai nostri amici dall'Italia. For anybody who doesn't speak Italian, welcome our friends from Italy. Atlas is a transatlantic association for the internationalization of startups. With us this evening is Ennio Andrea Adenolfi, Vice President of Atlas, and 35 wonderful people who are in the city to explore market opportunities to grow and scale their businesses. And a part of the group is Alto Robotics, who we've invited to demo with us this evening. Everybody, please show your hands. All of you from Italy, please, our friends, thank you. And give a big round of applause and a welcome. Thanks for being here, guys. Okay, how many of you are attending a New York Tech Meetup for the first time? All right, we got quite a few. Nice. So for all you joining us for the first time, our meetups are all about the tech and the market opportunities that each company is addressing. It's not about the business or revenue model. So those conversations can be had during the networking time or elsewhere. During the Q&A following each demo, please keep the questions focused on the tech and the problem or opportunity it's addressing. Otherwise, you're likely to get booed. Okay? All right. So before I welcome Jacob, I have 2 last items. 1, we love and welcome support to help us produce and deliver our programming. 3 ways you can help include attend as many events as you can, become an individual or corporate member or annual sponsor, or simply make a donation. You can do so by going to nytech.org/support_NYTA. And second, we're always curious about what's on your mind. Your opinions, thoughts, recommendations, and feedback are all welcome. You can easily do so by scanning the Jado QR code on the screen. Super easy, there's nothing to download, and you can provide answers in video, voice, or text. We also have a Jado word cloud up on the sidewall. Tonight's question is, what kind of tech would you like to see at future meetups? When you can, take a moment, scan the code, and let us know. Okay? And with that, I'd like to welcome Jacob Hennessy-Rubin, Executive Director of the New York Robotics Network. Hey, Jacob, where are you? There you are. All right, welcome.
I didn't get a fancy Madonna mic, so I gotta hold my hand. First, let's do another round of applause, please, for Doug and everybody here at New York Tech Alliance and all of the sponsors. Thank you. I'm Jacob, the Executive Director of the New York Robotics Network. So thank you all for being here. It was great to see that many hands that are new for this. I hope that is my fault. I'm going to take credit for it. But I want to share a little bit about who we are and what we're doing. So there's a lot of words, but ultimately, New York Robotics Network is here to empower and support the robotics community and ecosystem throughout the greater New York region. And what does that mean? There are a lot of startups, academics, industry partners, ecosystem partners, and venture capital and investment, all happening within this region that need a bigger voice and need to be more aware of what's around the world, of who and why it's happening here. And we aim to do that, or we are doing that. There's a lot of words there, but there's even more fun stuff on the right-hand side about how you can engage with us and how you can become a bigger part of our network, particularly as we are growing and expanding on a daily basis. Lots of things there to see, but you can also find it all just at our website, nycrobotics.org. We wouldn't be here without our sponsors and our founding partners, Interwoven Ventures. Lisa's here. Raise your hand. Where are you? In the back. If you're a startup looking and raising, go talk to Lisa. No. Monozukuri Ventures, which is also a fantastic New York-based but Japanese venture firm. SDPSI, that gentleman here, did they show up? Not yet. All right. They are a contract manufacturer out on Long Island in Hicksville, manufacturing motors, gears, other parts for robots. If you are in need of things for your startup, manufacturing or otherwise, parts or full assemblies, SDPSI is the place to go. And then Standard Bots, one of our favorite startups in our ecosystem. You'll hear more about them later today. You see the robot in the back. Lots of exciting things happening. Cybernetic Ventures is a strategic partner. They are a Boston-based but globally minded robotics firm run by Fadi Saad, founder of Mass Robotics. And then additional support from New Lab, Cozen, and Ideometry, a branding firm that has done all of our branding and website. More excited is the kind of work that we're doing. So we're doing these meetups, we're doing programs and services as a part of our member base, but a lot of that is how we engage the community in across a number of ways. And we are really excited to now be taking on the new New York City chapter of Women in Robotics with Natalie. Natalie, you want to come say a few words?
Hi everyone, I'm Natalie. I do UX research for robotics companies, and we're basically reactivating a chapter of Women in Robotics in New York City. They originated in the Bay Area, but they're popping up all over. So Women in Robotics is a global community supporting women who are working in robotics, who are interested in working in robotics in academia, in industry, and in entrepreneurship. So you can register to be added to future events there. You just type in your name and I'll have you on the list for future events. So thanks.
Thank you. I know we're throwing a lot of QR codes at you tonight, but I've got one more. You probably saw this on the screen coming in. This is a fun experiment that we're doing tonight. Seth, are you somewhere around? You want to come chat? Yep. Great. So Seth approached me at our last event and said, I have an idea for a fishbowl.
So it's just a contact information fishbowl. A lot of people here will be exchanging information all night long. It's totally voluntary. If you want to enter in it, Afterwards, I'll take the email list, sort through it, and then email everyone and share the entire list with everyone who enters into it. So just an easy way to enter and share your contact information.
Thank you. All right. Before we get started, just a little bit of housekeeping and run a show. We've got 6 great presenters. They're going to do short presentations, talk about what they're doing, talk about the work, and then allow for a few minutes of Q&A. We have a few folks here that have microphones to run around, so if you are interested in asking a question during a presentation, please raise your hand and stand up when you're asking that question. Do not remain seated. We're going to go through all those presentations, and at the end we'll break. More food and drink will come out, and we'll continue that networking, so we'll get more opportunity for demos and engagement and talking. All right? And with that, we're going to welcome our first presenter, which is Robert from Cargofish.
Thanks very much. I don't blame you for not trying that one. It wasn't fun to stencil on my uniform in boot camp. It's pronounced Di Domenico. I'll just jump right in. Cargofish is a containerized parcel utility system. So by that, what I mean is exactly what I'm saying there. Right now, the utility systems that are known around the world are water, sewer, that's 2 sides of the same coin, gas, electric, 2 flavors of the same commodity, and information by a variety of technologies. The closest thing to containerized parcel you are familiar with at the bank drive-through, where there's a little canister and it's pneumatic. They're also in about 2,600 U.S. hospitals, pneumatic systems. So I've been at this, just a little background, for about 14 and a half years. That's me in the same shirt at a conference in Denver, just in August. But it goes back pretty far. The International Urban Freight Conference I was at in Long Beach in 2015. And urban freight, that's the material needs of everyday living. If I asked a person off the street what fraction of those depend on the roads to get to and from your house, they would say, well, pretty much all of it, but the answer is 1%. We use about 100 gallons of water a day, and that's 99% of urban freight. It comes through the municipal system, it goes through the sewer system. It outweighs the fast-moving consumer goods by that much. National Renewable Energy Lab, I'll get another letter of commitment from my contact there, Kichow, who this was from June. I didn't win the grant from the DOE, but I'll be putting in for the National Science Foundation soon, and that'll have a slightly bigger budget, so hopefully success. So when innovators begin, if they go for the fundamentals correctly, they meet with success. And there are dozens of old videos and photos of failed flight machines, but of course this is Wilbur Wright in France in 1908. And once the fundamentals are attacked correctly and that's shared widely and it's recognized, there's really no limit to how big things can get. So the fundamentals of transportation, there's more detail than there ought to be on any slide, so we can come back to it for Q&A. But the left panel, the second column, the header, horsepower per net ton of payload. That's an easy one to check and see, and all the others follow from there. The energy intensity, the cost intensity. So we'll come back to that. All in all, it looks a little like this. This is a log plot of 4 aspects of freight across everything from arterial freight to last mile delivery. And the viable payload size goes anywhere from a couple of 100,000 tons on a ship to, 1 ounce prescription from left to right. The lead time, typically a month for a large ship, but for delivery, you want your food from where you ordered it in 15 to 30 minutes. The green and the red, they correlate pretty strong. Those are the specific energy and cost intensity and you need to divide by the same denominator the ton mile. What's a ton mile? That's when you carry a ton of freight 1 mile. So a waitress carries such a small fraction of a ton over such a short distance of a mile that it takes a half a year to a year to accomplish a ton mile. And so you're paying, when you tip the waitress, $30,000 to $40,000 a ton mile to have your food brought from the kitchen. You get a few things with it, but it's very expensive. Let's focus on the energy. And this box and whisker, so the typical payloads in the box, the whiskers are the extremes. Here, the smaller payloads are at the top. The units on the left are kilobtu's, thousands of BTUs. So ships on the ocean, they burn about, the biggest of them, 100 British thermal units of fuel energy per ton mile. A car picking up a couple of pounds from McDonald's is burning 100,000 or 200,000 BTUs per ton mile. Even a few million if you're just getting a prescription or mailing a letter. But this utility system, it's a rail-based system, and it can do small payloads for about the efficiency of long-haul trucking. A couple of order of magnitude improvement over how it's being done. If you put it on a linear scale, it's a lot easier to see how big a difference this is. The only things on this graph that come off of the lower peg are parcel delivery, bicycle freight. In that case, it's cost per ton mile, not so much energy, unless it's an electric bike. And Grubhub, sidewalk bots, drone delivery. They're all actually very cost and energy intense. So this is a little video I shot a few years ago in the basement. Whoops. I thought it played on the second button. Okay. I don't have a video for you. I'll get back to that at the end. So looking down that line, this is just for a sense of scale. Those are midget Christmas lights, and those rails are embedded over and under, and they're energized. That's not even 8 inches high. The payload that this carries, had the video played, there were 2 gallons on board. I have it on my phone, so come and see me. There we go. I'm back to it already. I'll show you the video on my phone. The drive unit, that's a slightly earlier version. I do have a static display. I have that drive unit here today. Now, perception, everybody can see the camels, but some of you have seen it before. It's not actually the silhouettes. The camels are the little beige lines. Those are their shadows. So I just wanted to emphasize perception because this ball bearing, we've seen them. You've never seen a bearing with rubber balls, though. It would go up in smoke. And yet there are 1 billion rubber bearings in daily use in just America. We call them tires. And they're the rolling element of a linear bearing. And they're not just under every truck and car, they're under every bicycle. And they generate a lot of heat and a lot of waste. Anyone heard of self-driving cars? Anyone ever been on one? Raise your hand, you've been on a self-driving car. The whole room should have lifted their hand because there's 3 self-driving cars right here. 900,000 elevators in America, 900,000 elevators in Italy, and they've been self-driving since before World War II. This is the president of Chile, and he's happy because a 6-inch diameter system got installed from the surface to 33 trapped miners who had been trapped for 17 days and lived for 52 more until their rescue on account of a 6-inch diameter. Now this is 8-inch diameter. This is serial number 1 of the new system. So it doesn't take much to make a huge difference, and this is all it's going to be. So it's been great dropping in, as my youngest son would say, but I got to hit the trail, as my oldest son would say, and I hope you'll come and see me at the New York City Fleet Show at Corona Flushing Meadows. I'll have about 600 foot of track in several vehicles, and I won't need a movie because I'll run it for you. That'll be in May of next year, so anyone have any questions, feel free. Thank you. Does that sound crazy to anyone? So, among all the utilities, are any of them failures? Is it easier if the power went out right now? Would the city operate more easily without water? It costs $1 or more a bottle for water in this city, and yet the water from the tap costs 2/3 of a cent per gallon. 2.3 if you pay for its disposal as well. It's a rolled up bill. But it comes from, on average, 100 miles away through the aquifers, and you could deliver that water and save all that plumbing, because plumbing's not cheap, but plumbing's effective. And every time a bridge got built, a bunch of ferries went out of business. Every time. The toll was far less than the cost to go over the ferry, and the service was far better. And that's every bridge you study. And delivery, bicycles and cars, those are just ferries. And delivery systems are bridges. And every utility bridges the last mile. So, are there any other questions? Yes, right up front. Okay.
I'm curious how this compares to, this looks very similar to a product in Austin from a company called Pipe Dream Labs.
Pipe Dream Labs.
Yeah.
I've talked with Garrett. So
Sorry. I'm just curious how this compares.
The difference is that they're going for an 18-inch diameter, which makes their material cost about 4 to 5 times as high. It also makes their installation cost about 3 to 4 times as high. With 18-inch diameter, for the same strength of pipe, you literally need 5 times as much material for the same sidewall dimension ratio. And when you install that, in the ditch that you put in an 18-inch pipe, you can put in 4 of these. So you might think something bigger is going to be able to carry more, but that's not necessarily true, because you can have more lines here. Additionally, I didn't mention, because it's the secret sauce, but that system uses turntables at every intersection, which is very much like traffic lights at the street. My system is more like a freeway, and there's only a divergence and a merge. And at those intersections, there are no moving parts. So this is rail vehicle that can be bumper to bumper and each go their own way. They can have a throughput that exceeds any lane of public highway in the US, probably initially by a factor of 2 to 4, ultimately close to an order of magnitude. Additionally, Pipe Dream 100% reliant on batteries, and every battery is a leaky bucket that you can only fill so many times. And to use your electricity through a battery is to concede that you're willing to spend 5 to 50 times as much as you would have spent if you had just got it from the outlet. And this is an energized rail system. So those are the biggest 3 differences. But I like those guys, and Garrett, I can't think of their names right now, but I spoke with 3 or 4 of them a couple of years ago. Anyone else?
Yeah. I'd imagine you would want to at least certainly start out in large, high population, high density population areas like a city or something like that. Would you be able to, or were you thinking of like already piggybacking off of existing systems and adding your tunnels to those as well? Is that the idea?
Thank you for the question. Thanks for the other question too. Both very good questions. But no, just like when fiber came along, it couldn't do anything with cable. And when cable came along, the phone lines didn't really help it. They might interchange at the hub, but this will be a new conduit of its own. And where did I want to go? Can't remember, but ask me that question later. Oh, the starting spot. In America, there are 7 million vending machines. Same number as in Japan. A little more twice the population here, though. And none of those vending machines refills itself. They're like the PDA, that thing that preceded the cell phone. It wasn't connected. And all of the labor is restocking those machines. I want to be right behind the vending machine at hotels and amusement parks to start. Nobody showed up there because they want to cook. They want convenience, they want value. And they can have it far better with a fleet of machines, each of which can dispense anything that's being brought in at the Sallyport hub much more cheaply because it's only being pushed, automated, when called upon and paid for. So that's my starting point. I can't think of a better one. Just like Bezos couldn't think of anything better than books. Thank you.
Thank you, Rob.
Thank you.
Make sure to go find him and see that video. Leila, you next. Let's do it. I'm going to let you introduce yourself.
Hi. Okay.
Hi.
So my name is Lila Porges, and I'm the founder and creative director of Procodress. And what we do is, wait. Sorry. Okay. So my company is Procodress, and we are 3D printing fashion with robotic arms. And a bit about me. So I studied architecture for undergrad and masters, but I always wanted to be a fashion designer. It was always my dream. So when I studied architecture, I took all the technology that they taught me about robotic arms and parametric design and thought, why no one is doing this in fashion? How can I take it to fashion? So everything I learned, I started to think in my head, how can this be translated to fashion design? And I applied to FIT, and I graduated from the MFA for fashion design at FIT. And I opened my company. And let me show you what I did with that. So as I said, I studied architecture. I learned about, I created facades of buildings using parametric design and 3D printing with robotic arms. And then I started thinking what will be my inspiration for the fashion collection that is 3D printing with robotic arms. And I always liked software engineering and computer science and math in high school. So I started to get some software and some computer elements and to look at them as inspiration and on the shapes of them, on the colors of them, and try to see where it takes me in the conceptual design way. And during the process, I researched and developed 3 methods to 3D print with the robots, which I will show you, and then I compared it to other methods of fashion and 3D printing by hand. So that's the lineup, all the sketches of my final collection. And let's start with the accurate method. So the robotic arm can follow every line in the space according to the code, even when it's very complicated and based on mathematical functions. But it also makes mistakes. So the material is sometimes dropping, and it comes from the gravity and everything that we have in real life. But these mistakes are also beautiful. And I started to appreciate them in the way they look as the process and not just the end result that is perfect. But we can see how the progress of this technology is. So in order to print accurately, I need to 3D scan the dress forms. And I'm designing the code with using mathematical functions. Sometimes it's fractals in this case. And this is how I design the prints. I print them on fabric, and then I print the same with the robotic arm. And I combine the 2 prints together, and I print it accurately on the shape of the body. And this was this look. And this is another print that I designed with code, and then playing with it, and that was this look. And the large-scale method. So the 3D printed materials can be completely recycled and returned back to what it was at the beginning. And I'm trying to use all the advantages of the robotic arm. So I can print very, very, very large-scale elements, and I can print in the space. So not only on a flat surface like a 3D printer. So with this one, I printed very large elements on the flat surface. And the material I'm using here is a 90% recycled carbon fiber and bottle caps. And you can come later and touch the material in my table. And then I played with all the elements that I printed in that method. And one of the things I printed just broke. The minute I took it off the plate, it broke completely to pieces, and I was very sad. But later I realized that these pieces that were created by what happened are also beautiful, and they can also be a look. So those are the 3 looks that I made with this method. And then I took, the large skirt and I put it in front of the robot, and I used the accurate method to 3D print on the large skirt. And I created these pieces, and that was that look. And the random method. So the random method is about just very simple way to use the robotic arm. It's just 10 points in the space, and the robotic arm is following them in a loop, and again, and the dress form is rotating. So after 8 hours of doing this with the material, it created that dress. And then I took the same method and I used it for an exhibition in New Bedford Research and Robotics. And it was 5 days of printing with this method, and people could come by and see how the process is going. And at the end, it was a full exhibition of other looks, and that was this look. And then so I compared it with 3D printing by hand. I used the 3D pen, and with many hours, I created that look. It wasn't clear what's going to happen. All the professors at FIT and other students asked me if it's going to be wearable, what's going to happen with it, and I just said that I'm enjoying doing this, and we'll see what happened. And yes, it was possible to take it off the dress form. It was possible to wear it, walk, dance. And I continued with this method. I used the other things that I printed with the large scale as a mold, and I printed on top of them, which created that look. And I kept printing by hand. I created this look as well. And this is a little fabric that I draped according to the shapes and colors of the code. And I'll just go all over fast this. And then I wanted to photo shoot all the looks in the environment of more of a magical, feminist, dreamy Disney kind of environment, surreal almost. And this is how we shot them with the models on different backgrounds. Yeah, and then they all walked the runway in Spring Studios in New York Fashion Week. And then I collaborated with Meta. So Meta wanted me to create an original reel of a dress. So I designed a dress with the material from Xstellar that is a bio-based EVA that is derived from sugarcane. And collaborated with New Bedford Research and Robotics. And we created that reel and that dress. And it got 150K views. So it was very cool. And then I started working on my own collection. This is one of the things that I'm wearing today. And I showed it also in New York Fashion Week. And yeah, you can, this is my company, and you can keep in touch. And I think that's the time for questions. Thank you. Any questions? Yes, there is one here.
Really amazing work. So
you.
are the dresses one use, or you can, like, the very
Yes, so
flexible ones can be worn many times, or how does it work?
yes, it can be worn many times. The dresses like the one I'm wearing, like this shirt that I'm wearing today, worn 20 times for photo shoots, and I wear them a lot, and I wore them for a full day. So this one particularly is very comfortable because it is printed on a fabric that is like lycra. It's very stretchy. So it can also fit different sizes. I sell them in small, medium, large, so it's very easy to fit and work with it. I have things that are more costume made, that you can put your own measurements, and then I have a software that takes the measurements and translate them into a code for the robotic arm to print exactly for a person.
Okay, thank you.
So.
Hey there, awesome presentation. I wanted to ask you, what do you see the next steps? Are you planning on scaling up, or what are your goals?
Yes, so I'm working now more on the accurate method. I'm working on the research of a new project, and actually it's now a patent pending, and it's about creating the whole dress without needing of any fabric underneath. So the robot will automatically create the whole dress without any need to connect pieces later, so with no labor work at all. And the idea is to scale it to have factories that will print automatically at the same time different dresses, maybe in different costume made, so different sizes and different designs. But yeah, that's what I'm working on for the next thing.
Thanks.
I'm curious for your the accurate printing method. How do you think about support structures and supporting the print as it goes up by layers? Like, are you adding separate support structures? Are you relying on the mannequin itself to act as support for the print? How does that work?
So yeah, my whole patent pending is about that.
Okay.
I can tell that it, like as you could see in the videos, there are no supports. And the mannequin is supporting the material as it goes. Yeah, that's what I can share about that.
Got it. Fair enough.
Hi, thank you for the presentation. So what materials are you using for the fabrics?
So in the presentation I used, some of it was PLA, but the other ones that I showed, as I said, it's 90% recycled carbon fiber and bottle caps. Another one that I'm using, and you can touch it later in the back, is bio-based EVA that is derived from raw sugarcane. And what I'm wearing is recycled PLA. And they all comes, I use them as spools or as pellets. Depends which method of the robot I'm using.
Thank you.
Yeah. Anyone else? Sorry? An ask for the audience. Honestly, I came here, so I'll give you a great presentation and you'll enjoy the night. And just keep in touch, I guess. Scan my website, put your email there so you can be on the list, and I can invite you to events that I have in the city. And yeah, that will be great. Thank you.
All right, next up we have Spencer.
Yeah, that was fine. Well, that's a hard act to follow. That was really amazing. And, you know, I was trained as a composer and an artist, so seeing somebody work so intuitively with robots is really inspiring. I'll just leave it at that. Okay, so, yeah, my name is Spencer Topel. I have a rather circuitous route into robotics. My dad formed a robotics company about 3 years ago called Electron Robotics. And he asked me to join and help after I was working on my own startup. So I'm one of these kind of insane multi-founders. So without more, I'll just tell you, our company's very small. Consists of my dad, myself, a really excellent former student of mine, Josiah Putman, and this guy Didi, who's been working with us on business development, also an independent investor. I'm surprised maybe Didi's here, not tonight. Okay, and Andrew Gilligan in software. So what do? Electron is developing robotics for food and other what we like to call high risk, high reward robotics projects. We were approached by a company called Sabao Meats. They're based in New Jersey. And they wanted to really work on solving this particular problem of bringing their product, which are sausages, from these smoke trees into their packing area. Very labor-intensive work and so forth. Once we started getting into this world, you know, to give you a little context, my co-founder Robert Topel, my dad and I, he comes from electronic manufacturing. I've done a lot of product design since being a professor at Dartmouth. And you know, what was very interesting about this universe as opposed to automotive or electronic manufacturing is that food is kind of like the Wild West of robotics. There's a lot of automation, but there's not a lot of new technologies in this space. And in particular, small and medium enterprise businesses like our first customer, Sabao Meats, they have a lot of automation, but they have a hard time getting attention from the main robotics integrators. So they've worked with companies like JLS, who's a major food provider, but it's hard to get them to work on anything less than a $2 million project. A lot of times too, for robotics, this is a difficult place to work. It's harsh environment, a lot of wash down, a lot of chemicals, and you have to adhere to like FDA requirements for food, strict regulation. So again, our first customer is Sabao Meats. They're a family-owned business. They currently have about $6 million worth of meat and packaging systems automation already, and we estimate that their kind of annual revenue is around 30 to 60 million. So they, in a given day, they'll produce about 250,000 to 300,000 pounds of meat product. So why is food so important? I mean, many of us know this because of the cost of food at the grocery store, that over the last 5 to 10 years has gotten completely ridiculous. I have 2 children, and we spend more on groceries than we almost do on their tuition per month. It's just, especially with growing teenagers. There's really an urgent need for this also in terms of labor. So the cost of labor is more than doubled over the last decade. And moreover, you might say, well, you're taking jobs away from humans. That's a typical robotics trope, that somehow we're stealing jobs from humans. The reality, though, is they can't find people to do this work. So it's not that they won't pay for it, that the labor isn't there. The other part is that AI and manipulation has to be kind of one and the same. At any one given food factory, there are many workers who are always checking at different stages the quality of the product. And lastly, I think this is really important for those of us working in robotics. Customers want to see a finished product. They want to see a complete system and a solution. If you go to a show like Automate or the PAX show or IPPE, which is the major food show, they want to understand how they can solve their solution with the least amount of pain. So we came up with an approach that's a 3D pick system to solve this problem of converting the product from these smoke trees into bins and then putting it on a conveyor so that the product can get scanned. And we treated it as like a total machine or system integration problem. In doing so, we learned and uncovered many problems in that cycle. So that led us to develop Proton Supervisor. Proton Supervisor effectively lives between the robotics hardware. We're an ABB integrator, FANUC integrator. We're working on Stably right now and UR, and other kind of PLC integration like Siemens or Allen Bradley, and between 3D vision systems and cloud ERP systems. And this is really important because, as it stands right now, many of the vision systems out there they work and they're mostly reliable, but they're not completely reliable. They'll still run into 10%, 15% of the time where they'll get stuck, they'll put the robot into a bad position, and the robot needs to be recovered. And so that's where having a kind of a secondary layer of supervision has really helped. So enough talking, I'd like to play you a video. This is the system currently deployed in the customer's factory. It's one of the reasons we haven't had a lot of time to put a demo together. So the customer, what makes this difficult is the customer has over 100 different SKUs in their factory, and ranging from small ones like this all the way up to nearly 4-pound sausages with very different packaging on each of the product. The other issue is that the cycle time of these, let's see if we can step into the next one here. The cycle time is very fast. So part of designing this is that we included manual pick with the robot so that when they needed to go faster at certain points in their shift, they could do so. So here the robot's waiting to place product after it has a moment to place it, when it has a free moment in the line. So that's when they take a shift change or they adjust something, the robot can continue to drive the product down the line. Okay. So, and then finally, I'll show you this last video here. This is a different scheme. So a lot of people, I would say most of us, including myself, drastically overestimate what's possible with a robot. I don't know if you recently saw the Tesla Optimus robot demo. Most of us know in robotics, after watching it for 10 seconds, it was utter bullshit. And it's not because the robot's not cool, it's not because the manipulator isn't cool, it's because the actual controls in the system, the kind of the AI part, the brains part, is very difficult. So even a simple problem like picking a sausage out of a bin is incredibly hard still. Why? Because not only do we have the computer vision part, knowing where the target is, but we have how do we get to that target? How do we prevent the robot from getting into singularities or other kind of poses that basically halt the robot? And lastly, when you have collisions and other kind of anomalies that happen when even we perform tasks, you know, for instance, right here, it crashed. How do you recover from those and keep going? And so I almost want to say that, like, as important to robotics is sort of novelty and computer vision and so forth, the other part is really reliability, repeatability, and kind of gaining that trust in the process. So, you know, it's kind of, as I like to say, robotics, and particular AI robotics, is really the contact sport of AI. So anyway, I think time's up. So thank you very much. We got one over here.
Thank you for your presentation. So you talked about reliability and novelty. So what part of your solution takes into account of providing reliable solutions across different manufacturing scenarios, and what part of it takes into account to adapt to the novelties occurring in different environments?
So I think maybe a third piece of this, which in addition is reliability, is cycle time, which is speed of operation. I was joking earlier with someone, I almost want to see the graph or generate the graph, which is the difficulty of a task against how much time something takes. So typically something, if it takes 7 to 10 seconds, is relatively a generous amount of time for something to happen. It's not too difficult depending on the complexity of the task. Like something like this, it's quite simple. If the task has to happen within 1 to 2 seconds, that becomes incredibly hard. So reliability is tied into that problem of cycle time. When I talk about reliability here, it means reliability under 2 seconds. Our pick time needs to be between 2 to 3 seconds on average, meaning we have some picks that are at 2 seconds and some picks that are 2.5 or 3 or 3.5, but they generally need to stay below 3 seconds. Otherwise, we don't meet the customer's baseline expectation. So in terms of novelty, I would say anything right now that's in 3D that requires path planning and it involves computer vision is still relatively novel from an automation standpoint. And if you look at humanoids right now, they're incredibly novel. They also have to account for their body position in time and space, and this becomes a very tricky problem. Our robot is mounted to a floor, and it has trouble seeing, you know, precise positions at speed. So you can imagine that, like, these problems they're not intractable, but they're very hard, and they require quite a bit of computation. I just maybe shut the room down. There's one person. Right here, but oh, okay. Well, I saw you.
Hey, thank you for the presentation. How do you see AI impacting, you know, the complexity of the robots that are more complex? How do you see the AI impacting that, and what do you see in the future?
Well, one thing to note is Electron, as my dad started out building manipulators. And when I joined the company, I loved the idea of it, and we pitched it, and we did a project with Verizon. But increasingly, we talked to VCs and other people, and said, "Don't build a manipulator." And I have to say, after working with ABB robots and other systems, I'm kind of in alignment. There's great robots out there. I think we need to build robots, but by and large, these manipulators are incredibly reliable. So our customer basically demanded we use an ABB robot, and I'm glad they did because their software environment's relatively good. But I will say that just on the reliability level, this robot doesn't need to be serviced for, you know, at least we estimate anywhere between 3 to 5 years minimum, most likely 10. So they're good for like many cycles. I think with some of the more novel systems we're seeing coming out, they have to go through that same evolution. You know, if you look at a company, we're working with Staubli, they made their business in the 1900s with looms for fabric and textile production in France. So they've been at motors and engines and designs and wheels for a very long time, and they brought that know-how to robotics. So I think with those novel solutions coming out, I think they need to happen. It's part of the evolution, but they're going to take time to become that reliable. There's one more.
Hi, thank you for your presentation. My question is about the video you showed with the people picking versus the robot. I don't really have a really good context on how fast a human picks versus how fast a robot picks. Is there a metric that you can give us that shows the efficiency, or what is the value at here?
I would say what we've learned, and it's funny that this comes up because earlier today I said I've been working in the factory for the last 2 or 3 weeks just helping them get online, and my approach has been very much like a kind of almost like an anthropological practice. I like help them with their job and gain their trust and be part of the system. I would say anybody who wants to do things with their customers, go do their job. I would say if we ever do this again, I'm going to tell our workers, like our team members, go work that job for 2 or 3 weeks and you'll see so much more. So to answer your question, a human being picks incredibly fast. They can just put the product down constantly, but it's a stop and start thing. And they need somewhere between 7 to 12 people operate a line, whereas a fully automated line here would only need 1 person. So you have to kind of look at it 2 ways. One is, yes, human beings can move faster, and so that's why we included the manual pick option. We were going to block the line. But the advantage of having the system is, and I'm already seeing how they're using it, they have one side which is manual, and the other side which is a slower line, which is the automated line, and they put their random odd jobs through that line, and they have the fast, you know, high volume stuff they put through the other line. What's not shown there is they have a separate robotic system that does Delta robots that runs directly out of the ovens, and those pick incredibly fast. So I think, you know, it's sort of a rabbit and the hare, or the tortoise and the hare problem. It might be slower, but you can run it all day, and it doesn't really need to stop. So you end up catching up, so to speak, with cycles. Thank you.
Okay, hello everyone. My name is, hi. Thank you for having me, by the way. It was a long journey, but quite fun. My name is Jordi Saglia, and I'm the CEO of Alto Robotics. So I'll tell a little bit of my story, my background, and then I will tell you this new journey of a venture building project, building Alto Robotics and its solution, which is Node, the iPhone of robotics for accelerated human productivity. So a little bit about myself. I have a background in mechatronics, an MSc in mechatronics, and from Polytechnic of Turin and Alto University in Finland. And I earned my PhD in mechanical engineering and robotics from King's College London. And then I didn't have enough, so I took another MSc in entrepreneurship and tech transfer from University of Genoa. I worked quite a few years in research at IIT. And particularly in robotics, you might wonder, but yeah, in robotics. I started a company and exited after 3 years, moving into technology, focusing on robots for medical application. And then I joined Amazon, running the innovation lab to build automation for logistics. Ran an impact accelerator with Founder Institute, some of you might know the network, and then Alto Robotics. I've always been working starting from the idea to the product, and particularly my past was focusing on medical robots, and today I'm not focusing on medical robots, but just to give you an idea of the systems I've been building in my professional experience. So some of them are here. Some of them became products, as the first one on the left, and the others are still on the way. But these are complex systems and wearables and things that interact with humans. And we've seen some of the applications, particularly when you interact with humans, things get very complex. Always starting from the understanding the pain and the need of the end user, and then going through design thinking processes, and then getting what is really the value that you need to deliver, and then working through prototypes and up to industrialization and commercialization. So going back to Alto Robotics. So we started in Q4 2022, so not so long time ago, backed by a VC, an Italian VC, and we started as a venture building initiative. So we didn't have any product, patent, or market as a reference. So we started looking at opportunities for service robots, and we started working with end users, understanding what were their pains in different industries. And particularly we focused on manufacturing, because we saw that there is a huge pain in terms of need for flexibility. So manufacturing companies today is shifting to high mix, low volume type of production, need flexibility. So they need systems which are very easy to be deployed, very easy to use with no prior training or technical skills, and that can be deployed very fast to cope with very much increasing personalization required by the customers, disrupted supply chain, and lack of labor, as we saw also before. Standard automation doesn't really apply here because it's rigid and very costly, and the humanoids, yeah, you've seen many videos, but it will take time before they will become mature technology. So we need adaptability, systems that are plug and play that can scale fast. So our solution is Node, is a physical AI agent, which is a mobile robot that can actually be deployed very fast with very few clicks, like a consumer product, and it can deliver material and information across the shop floor, and so it becomes the body of the operator. So it's really the new helping hand in production. Very dexterous, can navigate autonomously and collaboratively. It's intuitive, as I said. It's really like a sort of a consumer product, so it can be set up very, very easily by any person, and highly flexible also in its physical shape and configuration, so it can be adapted to any environment. Patented, design is registered, and is also be recognized as one of the best designs by the Redot Award in 2024. So here you see some of the examples. So it can turn out to be a physical movable workstation, or essentially a smart card that can transport material whenever you need. So we have proven this system to be very effective in business. We ran a number of POCs and tests with our customers, and we showed that we can do 3 times more the delivery missions in a day than usual, because most of the times these missions are carried out by humans and they are slower than robots usually. We can save working times, and we can of course reduce downtime, which is a source of cost for the manufacturing company. So overall, the efficiency is improved, and this means savings for the manufacturing companies. We stand out of the crowd because we are highly collaborative and flexible in being applied to different type of applications, and we, differently from others, we are not just vertical, and we are not an automation component which needs to be taken by a system integrator and implemented in a particular application. We worked, as I said, directly bottom up from the end user up to the product, essentially working on 2 development streams. One was to build something very fast, so using existing technologies, using commercially available robot platforms to build on top of that. In terms of hardware and software, you'll be able to test very quickly and understand what is the pain and how this product is really effective, or whether it's effective or not for the customer. And on the other side, building the technology. So we are builders. We build the hardware and the software. We started with platforms for navigation development, autonomous navigation development, down to developing every single component of the full product and the full robot. These are the characteristics. The robot is collaborative as well as autonomous and dexterous. And here is a little video. Let's see if it goes. Yes. Showing our beta prototype. And essentially it's been designed. Can we remove the audio, please? Thank you. So it's been designed to be autonomous and omnidirectional, so the wheels can turn and can be configured so that autonomously, so that the robot can move in a very dexterous manner in any type of environment. It's collaborative, so I can, through gesture recognition using machine vision, I can tell the robot to follow me, so the robot will recognize me. It will just follow me through my through the path I want to take. It can be loaded, and all the information related to the material I load onto the robot can be collected by the robot. It can also be physically moved and adjusted by the operator, and this essentially shows the full flexibility of the system to be used by any type of operator with no prior skills. We are a team of 17 people based in Italy. We are looking to possibly move to the US very soon. We have a lot of experience across different industries. We have PhDs and engineers, software engineers, mechanical engineers. We have a background in different industries, as well as a background in with a number of publications and scientific publications and patents being in our records. That's it. If you want to know more, I'll have a stand back there, and I'll be happy to answer any question. Thank you.
Hi, I'm Smith. Thank you for the presentation. Have you thought of adding a robotic arm to the system as of now?
Yes, this is a common question we get from customers and users, but we decided not to do it because when you add manipulation, as we saw also in the previous presentation, the application becomes very specific, while we want to be very generic. We want to be able to deliver the robot and take out the robot out of the box by the end user and just use it from the first minute. And so when you add a manipulation on top, you need skills to set up the manipulation and to teach the robot and to make it very repeatable, which is not the case for us. Yeah.
Thank you.
We have one question up here.
Thanks for the presentation. So many AMR are used for logistics and manufacturing in indoor environments. I see you listed Alto use case, for your company. Can you elaborate what are the challenges for the Alto use case, especially for the sensors on the robot?
Oh yes, yes. So there are many AMRs out there as well as AGVs, but most of them are automation components. So they're smart cards. They have autonomous navigation capabilities. But usually what happens is that a system integrator, the company that needs to implement an application, as we saw before, needs to ask a system integrator to develop that particular application. And then it's sourcing the particular components, so the smart card from a manufacturer. Our goal is to have a physical companion so that you can just order it, then get it, take it out of the box, configure it with very few steps, and then use it as you please. And this is particularly to cope not with processes that are somehow that you are able to generalize, but with all those tasks which are not foreseen before. So like you have to cope with transporting material and information across processes to cope with the non-foreseeable tasks, essentially. So the challenges are, of course, make it reliable in terms of navigation, autonomous navigation, also particularly in contexts which are not very well structured, but we're getting there, yes.
Okay, thank you.
Hi.
Hi.
Yeah, I mean, I think given the vision that you just articulated, maybe this isn't the thing, but related to the manipulation, if someone has sort of pick and place or some kind of structured automation system, do you have ways to integrate with their structured automation system to load these things and then deliver them to like humans, or is that something you're thinking about, or is this really aimed mainly towards the unstructured human-to-human conveying kind of application?
It will be the next step. So yeah, you're right. So for example, we have companies that are saying we have manipulators which can pick and place and load the robot, for example, like fixed manipulators or even humanoids. So yes, it's something that we will be looking at in the future, because of course it's a natural evolution, I would say. But to start, we want to get the easy things done, and that's why we focus on just a robot alone.
Okay, thanks.
Thank you.
Hello everyone, amazing presentation so far. I'm Anton Morgenmuth, co-founder and CTO at Silana, and today I'm going to share with you how we use deep tech robotics and artificial intelligence to transform the fashion industry. At Silana we envision a future where fashion production is both efficient but also sustainable. This is more than just improving how garments are made today, but it's more revolutionizing the approach how garments are produced, and especially where they are produced. By combining robotics and sustainability, we aim to solve a problem that's deep-rooted in one of the oldest industries in the world. The fashion industry, as it stands today, is one of the biggest contributors to environmental issues. First of all, the fashion industry is responsible for more than 10% of global CO2 emissions due to extremely long and an extremely complicated supply chain. The second topic is the exploitation. 93% of workers, they do not receive a living wage, and unfortunately the fashion industry is set up in a way with fast fashion cycles that large producers have to rely on labor in cheap, still developing countries. The last point is the economical fallout. We talk about 6 to 9 months in lead times, which are pretty hard for brands because they have to predict the trend 6 to 9 months in advance, which leads them to usually order more products that they actually need, and eventually 30% of all products bought by the brands aren't even sold. So we wanted to tackle this problem, and also others have tried it. Big brands like Adidas and Nike have tried to tackle these challenges through automation, but their results weren't as expected. There are some reasons for that. They heavily tried to automate the production process of fashion by combining a lot of experts together and a lot of funding to build a machine that can produce fashion just on its own. We took a completely different approach to automation. We were like 3 friends starting out of university. I have a background in automation engineering, and what you read in every automation textbook is like, if you want to solve like a problem with robots, just look how humans are doing it. And that's exactly what we did. So we utilized first principle thinking. We actually broke it down. What is the reason why the production has to be there? And then like how can we automate that step? The reason for the production to being there is actually just the sewing process. So like for most of the steps in the supply chain, there are automated solutions that can be done with robots. Besides the sewing process. So like all the clothes that are worn here in this room are still sewn together by human labor. And why is that the case? The reason for that is that handling limp materials like textiles is extremely challenging, especially for robots. There are solutions in the automotive sector that you just, sorry, is this like, should I go far away or? Okay, closer. Thank you so much. Processes that can be just introduced in the automotive sector can't be in the fashion sector because the limp materials are quite hard to grasp, and that's what you see here. So like we bottled it down and saw like the actual problem that we need to solve is like find an approach to handle textiles. You can see 2 videos. Sorry. Okay, I can show you them later, but basically we developed like 2 areas of gripper. A surface gripper that's based on vacuum and magnetic technology that we use to grip and grabs like full laid out fabrics, and then on the right side you can also see like what we call a point of interest gripper, where we can grip textiles in different shapes, and eventually we bring them together and sort them. So what we did is like we found easy solutions for each manipulation step a human worker would do it with a garment and automated it. We brought it together into this cell. Right now we are focused on tank tops. That's what we are producing. We start with already pre-cut fabrics and then bring them together to a finished tank top. With that we talk about like a production cycle of 2 minutes per tank top, which is amazing. And due to that, we can decrease the amount of human workers that are needed. So instead of like having 14 employees in a line for a t-shirt, it could be 2 to 3 that just do like the sleeve. This results in 80% cost savings and 38% less CO2 emissions. And the great thing is with this like cost savings, we can enable nearshoring the production back to the US, but also back to Europe. And yeah, I also brought like a video. This video is already 2 years old of our first prototype for this tank top robot. I know the video is super long, but we kind of like it and are very proud of it. This is actually the first robotic cell that actually can fully automate the sewing process of a tank top. We also brought some of our samples with us. They look way better than the ones in the video. But yeah, we're very proud to say we already pre-sold 8 of our robots. We start rolling them out beginning of next year, and there are more than 250 robots already in our pipeline. But we think we start with the first 8 and see how they work. Hopefully they do good. And yeah, there's also like a lot of applications for these soft tissue grippers that we developed in the automotive sector, aviation, but also healthcare. Yes, but now I've been open to your questions. Thank you so much. And
Thank you very much. I saw in the video that the sizes were small, medium, large, XL. So do you have any intention to go into more bespoke tailoring at this point, or to feed people's specific sizes as inputs?
Yes, so our initial plan was actually to build like a robot that can do customized sizes. For our customers right now, they usually try to utilize automation for products where the volume is quite high. So like from our technology level and also from the software side, we could do like custom fittings in the next years, but right now for the first machines, it's just like specific sizes that are pre-ready set up.
Thank you. So for the future, for making different kinds of clothes, how are you going to adapt your cell? Are you going to have to make a whole different kind or just a different end effector?
Good question. So you couldn't see it in that video, but like the way we set up our like subsystems, like each subsystem manipulates the garment in the way we want it to do, and like for the end customer, they just pick and choose what they want as an output, and we just store them together.
So you're making custom cells for each person?
Exactly.
Okay, great, thank you.
Thank you for the presentation. What do you see your next challenge would be? Next to tank tops, t-shirts, what is it, coats, shoes?
That's an interesting question. I think like getting the reliability up and like parallelize some of our production processes. So like we try to optimize our existing cells first before we move to like different types of garments. But like eventually like t-shirts and tank tops and like also long sleeves and hoodies, there's like a huge sector that we try to solve, and then we go to like more difficult things. But also like for like dress shirts, for example, or like custom tailor-made types of garments, the end customer, they are willing to pay more for like having them custom tailored. So it's like not really a market we want to go into in the next years.
Thank you.
Thank you so much. Sorry.
Hey, what's up, man? Just a quick question. Fabrics in different temperatures, different humidity settings, different types of fabrics. What sort of sensors are in the machine that can handle those different conditions?
I think we can talk about this later in the setting. Most of the like type of sensor and also like how we do the sensor fusion is covered by our IP, so I cannot openly talk about it here. It's also taped, I've heard. So, but like, thank you so much for the question. I will follow up with it later. Thank you. Thank you.
Hi, I'm James Gordel. I'm here for Standard Bots. I'm a founding member of the company. Been working on this since day one. I'm really excited to share with you all today some of the new things that we're doing in the AI space to make training a robot in a completely different manner, very accessible to anyone. Like if you've ever played a video game or you can use a cell phone, you're going to be able to train robots for AI. So a little bit about myself. I am a designer by trade, kind of fell into the robotics space. We've grown from, you know, a two-person company at the beginning. Now we have, I think, over 50 employees. Very skilled team. Some of them are here tonight. Thanks for being here. We came out to the first meeting here, and I'd like to thank Jacob for inviting us back. And we're actually a founding partner with y'all now, so I hope to come out to a lot more of these. So shout out to Jacob, thank you. So what I'm going to show you today is kind of a device that we're building that's going to gather data to show the robot what to do outside of a traditional rigid structure where, you know, you go to point A and you go to point B and your pickup's always in the same spot, or you have to index something. And this is kind of where we see the future of robotics going. And I think you'll find it some very compelling
How's the echo feel?
video. So right here we have Elijah. He's just using one of the early prototypes of the device to train, just putting a barrel plug into like a USB. So we kind of wanted to make a couple, we wanted to make the demo more fun, so we thought we would do soda pouring. So you might recognize that guy back there. Used to bartend in college, and now I'm back teaching robots how to do it. So it's kind of crazy. Come full circle. That was 20 years ago. So right here you see it pouring a soda. So we've trained this on like 50 demonstrations of pouring a soda. So we're really trying to get the amount of demonstrations down that you will have to do to train a certain behavior within the robot. You can see that it's reacting real time. So there's no code here. It's just generating, its path, like similar to a large language model. It's using a predictive model policy to know where it needs to go next, and it knows where to follow it. We've had very high success rates with very few demonstrations needed. So we really want to crunch that number down as far as we can, so the robots will be able to learn with very low interaction. We also want to get the robustness of these models up. So when you train, there's a couple things, and I can't really go into it, but there's data augmentation techniques where you can really have these models perform on a robust level. You can bring this, outside of, where it's trained, and it'll work. So we could potentially be setting up for people to train at a, provide the data to train at our location, and then we send our product over to them, and then they do, like a little bit in their environment, and then now we have like a very robust AI solution. And right here, I think you'll just see me kind of messing with it a little bit more, and you can see how it just on the fly reacts. Very, I gotta say, it was kind of unnerving. It was like, it felt like the machine was sort of coming alive, or like trying to take, a treat from like a dog. Like it didn't, bite my hand, so, we're good there. And then we have an ask for the audience too. We're growing very fast. Like I said, we have 50 employees. We're hiring, feels like one employee a week at this rate. We're looking for a couple senior software engineers within a full stack engineer, AI product, and looking for embedded control systems. There's another position available that we'd like to hire for a process engineer. So if anyone knows any of these people or are interested in a role like that, please come see me, and we can get your information and get you in contact with HR. I have the robot in the back, so if anyone wants to come talk about it and play with it, feel free to approach me. Again, my name is James. And I think I had one more slide, but I don't think it got on there. Yeah, that was it. So yeah, I can show you, since the slide didn't make it on, I'll show you the product I'm talking about. You saw the prototype right there. So we're doing multiple prototypes, refining it. We do a lot of 3D printing, rapid prototypes. Very fun place to work. So if there's any interest at all, again, please come say hello, and tell me about yourself, and any questions I might take, I'll open it up to y'all in the audience.
So I'm curious why. To me, this seems like it's using AI to help people avoid kinematic suffering, for lack of a better term. I'm
That's
curious.
a new one.
I'm curious why that required you guys to build your own hardware, though.
So we wanted to be the platform that, you know, you hear the word democratize quite a bit, right? We wanted to democratize robots, right? We went out and we saw that in the space it was very hard. You need integrators. It's very hard to program a robot. So I'd say we kind of come from a tech perspective and then into like the hardware space. So that has been challenging, but I stand by our product, and you're welcome to come jog it around and look how routines are made. It's no code, but we also have an API, so you know, a lot of cool stuff's happening on the back end. We have Amazon is using 2 of our robots to play chess versus each other with large language models. If anyone's going to be at AWS next, we will be there at a couple different booths and representations. So swing on through if you get to make it out there. Yeah. Does that kind of
thank
answer?
you.
Yeah. Anybody else? Come on over here.
Awesome. Thank you for the presentation and cool videos. I was going to ask, this pipeline of demonstration to putting things on the robot, we saw it on the pouring task. What other tasks have you tried to do this on?
Yeah, so we've done some sorting tasks. We've actually done some stuff too with garments, folding. There's the one I'm very interested in getting to, but we have not done yet, is like agricultural picking. What we think this technology is going to really open up different verticals in the robotic space is for you know, organic shapes, fabrics, like anything that's not, you know, that a modern vision system might have like trouble identifying, right? And so as we start to tie all this tech together, what makes this cool is we can bounce back and forth between traditional robotics and this AI step. You know, this technology is happening so fast, so correct me if I'm wrong, but I do believe that we'll be one of the first robots to actually have an AI step where you can just easily just drop it into your routine and kind of manage all of that data like right there in our, you know, in-house made user interface, also on top of our hardware. But yeah, we've done quite a few things. There's been a couple things that you know, you would think like worked really well, but we're going to add different sensory levels on. Like for example, we did spill cleanup. All right, so for that we want, you know, depth data and not just like RGB cameras and things like that. So the product's rapidly growing, but yeah, I'm available to talk about it after this.
Cool, thanks.
Gentleman in the back. I'm a little bit over, so I'll try to make this answer quick.
I was just curious in terms of other robotic arms like Quinoa robots or something like that. How does it compare in terms of customizability? So for especially like academia or something like that, if you want to especially customize it for a particular application or you want to test out something. So since your software, I think it's supposed to be more simplistic and easy for the end customer to use.
Yeah.
Is that customizability also allowed?
Yeah, so pretty much anything you can do in the UI, you can also do with the API. That is not my specialty, but I can, if you have other questions, I can definitely direct you to talk to some of my coworkers that might be able to answer that for you. Mm-hmm. All right, thank you very much.
Thank you. I'm just going to add, since James mentioned it thoroughly, that the standard bots, the one you see in the back there, the what are we at? R01, they're actually made and manufactured in Long Island. So the whole part is there, which is a very important part, that they're manufacturing them in the US from the ground up. The chips, the motors, the gears, the housing, everything is done right there. So it's more than just the AI that they're doing. If you want to know more and see more videos and see scenes of the factory, New York Post, the New York Next feature, just did a feature on them, and there's a whole video and interview with Evan and team from StandardBots. So we're going to get into the community ask offer next. We're going to get a mic stand coming up. We'll put it in the middle. If anybody wants to ask a question, have an offer, make an announcement, let's get in line and stand up front. Give you a few seconds to do that. That's good. Thank you. Don't be shy. Let's get in line. First come, first serve. Anybody? Anybody need a job? Looking for funding? Wants to just say hi? Has a birthday? Appreciate that you're first.
Sure, yeah, it's hard. Hey, Jonathan from Kyber Labs. Sorry, we're doing a dual arm system for manipulation, and we're going to be looking for a machine learning engineer to join our team. So, find me.
Hi, my name is Nishant. I have a small company in New Jersey. We cater to medical robotics and medical device development in general. I mean, in particular, but in general, we serve lots of startups for their hardware development needs and firmware development needs. We have a full-fledged PCB manufacturing and assembly lab in New Jersey. We do all testing, and we do jigs for testing the PCBs. So anybody who needs that service, find me. Thank you. The company name is Quartech, New Jersey. Thank you.
Too short. Hello, everyone. My name is Esosi Gadaro. I wanted to ask, who's a startup founder in the room? No one's a startup founder in the room? Okay, great. Any investors in the room? Okay, some shy investors. Okay. I wanted to invite you all to an event I'm doing on November 8th called Accelerator Con. It's going to be at the Brooklyn Navy Yard, and it's this opportunity to find different accelerators who will be essentially reverse pitching and learning more about the 3,200 accelerators we have in the United States alone. You'll be able to learn more on acceleratorcon.com, and see you November 8th. Thank you.
Thanks, Asosa. Hey everybody, I'll be quick. Hey, I'm Ryan. I'm new to the New York area, so always looking to meet good people building hardware. I started a company called SEB, and we're helping embedded engineers do their coding much faster. So we have a Figma board with code generation underpinning it. We're raising a $1.5 million round. We just secured our first investor last week. Very excited about that, and we're looking for anyone that's passionate about robotics but has a software background for our first employees. So hit me up. You can find us at heyseb.ai, and we'd love to hear from you. Thanks so much.
Hi, everybody. My name's Sebastian. I am an electromechanical engineer with, I think, 3 or 4 years of experience in the industry, looking for a job. If you have any interest in hiring me, that would be great. Come talk to me. I have experience in electrical engineering, electronics manufacturing, specifically SMT manufacturing. Would love to talk to you. Thanks.
All right, I'll try to be quick. My name's John, and I am here to introduce my son, who is abroad right now, but he would have loved to have been here. He is a junior studying at Vassar College, and he's a cognitive science major, but he is has taken more of an interest in robotics. So he did a summer research project building a humanoid robot. And yeah, I would, if you have any interest in learning more about him and seeing his resume and some of his work, come see me. Thanks.
Hi, my name is Karan. I'm a master's student at Cornell. My main focus is in robot learning, but I'm really interested in sort of the robotics and machine learning space. So if anyone's hiring in that area, let me know. Thanks.
Hello, my name is Rudy Weinberg. I'm an electrical engineer with experience with microcontrollers and electric motors. And in addition to my day job as an engineer, I like to do freelance projects. So if anyone has any robotics projects, you need someone to do part of it, whether it be circuit design or microcontrollers or actuators or anything like that, feel free to let me know. I'll be around. So thank you.
Hello, my name is Kevin Gu. I'm a founder of a startup called AstroBeam. So we are building a sub-terahertz imaging radar for autonomous robots. So I'm here to try to understand the needs of the robot companies and end users, how we can help you to make your robot to operate in a more reliable, in harsh environment. Please talk to me. Thank you.
Hi, my name is Jay Song, and I just recently finished my PhD. Actually, my research aspect was the humanoid, but my experience is very broad, from the mobile platform and to manipulate, and including manipulator, dioram, all those stuff. So if you have any interest in me, please talk to me. Thank you.
Hello everyone, my name is Steve. So this is my third time in the NY Tech Alliance meeting. So I've been here every month. So I run a company called New Starts. So I'm the co-founder and CEO of New Starts. So we do help help startups from ideas to IPOs. So the recent Copilot launch, which you guys all were excited about last week, that was from my team. And so we also a proud partner with Techstars. So we help startups to secure partnership with VCs and build a team. So we operate in the build, operate, and transfer model. So if you are someone who's looking for services, please do find me out there. Right? Thank you.
All right, last two.
Hi, my name is Kirill. I'm an interior designer, and my first time as an event of that sort. I have an experience of 30 years. I have an office of 15 people. I'm currently working on a startup involving interior design and AI. My first time at the event, I'm desperately looking for a CTO or any technical person. I might have a potential investor. I'm super passionate about my idea, about my project. I very much would love to talk to someone, anyone who might be interested, so I'm here. Yes, so CTO, interior design, AI.
Okay.
Hello everybody, my name is Shiraj. My background is in robotics and machine learning. I did my PhD about 12 years back in that, and then last 12 years I've been doing work. I spent 5 years building robots in the energy sector, in inspection maintenance, 3 years in the defense sector, and the last 3 years here in the self-driving car space. I'm just interested in the community, meeting people, but if I'm also interested in, I have some ideas. If you're interested in co-founding, definitely interested in having more conversation on that. So thank you.
All right, we're going to take 3 more. 1, 2, and 3. Okay, come on up, guys. Yes.
Hi everyone, I'm Michele, co-founder of Elevate, an hardware startup. We're doing a technology for smart surface. That's this very reliable touch sensor to be applied in any type of surface to innovate how consumers interact with everyday products. And if anyone could be interested in our technology, please talk to me, or investor or corporate. And thanks to Atlas to invited us in this great event. Thank you.
Hi everyone, my name's Palash Barjatia. I just graduated with my PhD from Columbia University. My thesis was in the area of 3D printing of cement and concrete, and currently I'm looking for jobs in this space, 3D printing. I have 3D printing experience and also like a material science background with material flow behavior. So if you have anything or if you know anyone, please find me. All right, thank you.
Okay, thank you. And last one. Come on up.
Hi, this is Krupanch. I just graduated with a master's in robotics from Stevens. I have around 2 years of internship experience with Cobots, Siemens, ABB, and FANUC. And yep, I'm looking for a job right now. Thank you.
Okay, that's it. Let's see. Our next meetup is going to be on Monday, November 11, when we'll be celebrating the 1-year anniversary of Civic Hall and the amazing tech our members have developed here. So registration will open soon, and we hope to see you there. And that's it, guys. That ends things for tonight. Thanks for coming. Enjoy the bar, the food, and we'll see you next time. A group photo? Okay. Do we have Leela? 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 Leela?